Problem 3, I need to find out value of this load resistance to get the maximum power from rest of the circuit, and also I need to calculate the maximum power at this load. I am following maximum power transfer theorem. First I need to find VTH. For that I am removing this load and I am going to calculate this open circuit voltage. Here, what is this open circuit voltage? Voltage across X and Y. As no current is flowing through this 5 ohm, so potential at X is equal to potential at A. So actually VOC is potential at A with respect to point B, which is equal to this 10 ohm multiplied by current through this 10 ohm resistance. So this one. Here a negative sign is here. Why this negative sign? Because I am using the nomenclature as BAB. So potential at this point with respect to this point, as current is flowing down to up through this 10 ohm resistance. So here this is positive, this will be negative. So BAB is just negative of this magnitude. So 10 multiplied by I. Now I need to find out the value of this I. This I will flow only because of this source. So what will be I? I will be this 50 divided by the full resistance, that is 1 plus 3 plus 10 plus 1, that is 50 divided by 15. So 10 multiplied by 50 divided by 15, ultimately I got minus 33.33 voltage, which is VOC, that is VTH. Next I am calculating RTH. So removing this load and replacing the source with its internal resistance, as this is voltage source that is shorted. So this part is equivalent resistive network. Here up to this 3 plus 1 plus 1, that is 5, is in parallel with this 10, and equivalent of this is in series with 5. So ultimately I got RTH is equal to 8.33 ohm. So this is the equivalent Thevenin circuit. VTH is equal to minus 33.33 volt, RTH is equal to 8.33. To get the maximum power at load, the load value will be equal to RTH, that is the source resistance. So see, RL is equal to 8.33. Using the formula, the maximum power value is equal to 33.34 watt. Now using the simulation to say whether my calculation is right or not. Say this is VTH, this is RTH, which is equal to the load resistance is similar as RTH, and in the main circuit also I have used the same load resistance 8.33 ohm. Now if I get same power in main circuit and in equivalent circuit, and if it is 33.3, then it can be confirmed that my calculation is perfect. Now running the simulation. Say in main circuit power is 33.3 watt, in equivalent circuit also power is 33.3 watt, and also it is same with my calculated power.